Today we are going to solve the problem 8.19 of Griffith third edition Introduction to Quantum Mechanics. Before going to the details of the problem, kindly subscribe my channel in order to get my updated videos. Also share and join for the growth of my channel. The problem 8.19 is based on the variational principle. Uh, uh, that is problem 8.19. Find the lowest bound on ground state of hydrogen you can get using the Gaussian trial wave function. In variation method, we will take some trial wave function and we will find out the solution. So the trial wave function is a Gaussian one. That is psi of r is equal to a e power minus p r squared, where a is determined by the normalization and p is the adjustable parameter. So in order to find out the normalization constant, we got to integrate psi star psi uh, over t tau, where t tau is a small volume element. In the case of radial coordinate system, this t tau is area multiplied by the thickness. That is, area is 4 pi r squared and multiplied by TR. TR is the small distance, thickness. So area into thickness gives you the volume. So, and this is a small volume element. And the given wave function is a e power minus p r squared. So if you square it, you will get and take a outside the integral modulus a squared e power minus 2p r squared, and this one is must be equal to 1. So now you can take out the constant outside the integral. Already there is minus modulus a squared, and we are taking this 4 phi also. Then this will become e power minus 2p r squared multiplied by r squared tr must be equal to 1. Here, remember that the limit of the integral is 0 to infinite. In order to use the Gaussian Gaussian function, we have to change the 0 to minus infinite to plus infinite. So naturally, you will get, if you take half of this integral, you will get 0 to infinite. So if you take half, then 4 pi will become 2 pi. So remaining things are same. However, using Gaussian wave function, this integral will be of square root of pi alpha power minus 3 by 2. Here alpha is 2p. This is alpha 2p. So you replace this integral by this value. Alpha of course is equal to 2p whole power minus 3 by 2. If you substitute, then yeah, if you substitute and simplify it, you will get modulus a squared multiplied by pi over 2p whole power 3 by 2 is equal to 1. That means modulus a squared, you bring this to the other side, which will become 2 pi, just inverse of this 2p over pi whole power 3 by 2. So we have found the square of the normalization constant. Now our task is to find the total energy. First we will find the kinetic energy, which is equal to the expectation value of kinetic energy. So the kinetic energy operator is minus h cross squared. You know very well, it's del squared. It's a p squared operator. So p squared over 2m is the kinetic energy. This is equal to p squared, momentum squared operator. So uh, here you have minus h cross squared. So this is minus h cross squared. Del squared is a momentum squared operator. So you have minus here. Then you replace psi by the trial wave function, which is e power minus p squared del squared e power minus p r squared. Here e power minus p r squared del squared e power minus p r squared and this modulus a squared. And what about this tau? Tau is a small volume element. In three dimension, it is equal to 4 pi r squared t r. 4 pi r squared is area. Area multiplied by thickness is volume. So here you take all constant outside. So this will become minus modulus a squared h cross squared over 2m. This 4 pi I am taking out and r squared is inside the integral. So r squared e power minus p r squared del squared e power minus p r squared. Here the del squared operator. Uh, Here you notice that wave function purely depends on r. So the del squared is the radial part of the operator. That is del squared radial part of del squared is 1 over r squared t over tr r squared t over tr. So if you replace a del squared by this operator, then and del squared e power minus p r squared will become this term will become this one. That is, I have not done this differentiation. It's a very simple and straightforward. Of course, I have given this as a separate lecture. Which is equal to minus 2p del squared e power minus p r squared is equal to minus 2p 3 minus 2p r squared e power minus p r squared. So now you replace this del squared, this exponential term, then you will get here you notice that this is minus 2p. So minus of minus will become plus and a squared is 2p over pi power 3 by 2 and you take this 2p outside. Already minus and minus cancelled out, will become plus. So I have taken 2p outside. Then that 2 will cancel with this 2. So this will simply become m. So you got 4 pi h cross squared p. Here I am multiplying, maybe I will use different color. I am multiplying this parameter, that is r squared, this exponential term, by this, because this is del squared e power minus p r squared. Then you will get this 3 will become 3r squared and minus 2p r squared will become minus 2p r power 4. Of course, I have taken minus 2p outside and here this e power minus p r squared multiplied by e power minus p r squared will become e power minus 2 p r squared dr. Now the expectation value of kinetic energy is this. We got this. You forgot about this constant. You concentrate only on the integral. So this can be separated into two integral. Three integral minus infinite to plus infinite r squared e power minus 2p r squared dr minus this 2p I am taking out r power 4 e power minus 2p r squared dr. Now, if you integrate this, this is the Gaussian integral, which is equal to, you leave that 3. 3, this is 1 over 2 square root of pi. This alpha power minus 3 by 2. Here alpha is 2p. So 2p power minus 3 by 2. And what about this? Minus 2p, you take it as it is. Then if you integrate this, you will get this blue color I have shown 3 over 4 square root of pi 2p minus pi by 2. This is standard Gaussian integral. Now what I am going to do is I am going to take 2p minus 3 by 2 outside. Then this square root of pi also I am going to take outside. Here I have square root pi and here square root pi, and I am going to take this 2p minus 3 by 2 outside. Then what about this? Here I have taken pi also outside. This is square root pi. So first term will become 3 by 2. Then next term, since I have taken 2p power minus 3 by 2, this will be 2p minus power minus 1. Of course, you have 3 by 2. Here you have 2p. So now this 2p will get cancelled with this 2p. 2p inverse actually. This will get cancelled. Then what about this? Uh, uh, this you can see this 2p power minus 3 by 2 will get cancelled with this 2p power plus 3 by 2. Similarly, the square root of pi into square root of pi is square root of 3 by 2, which will get cancelled with this square root of so 1 over pi 3 by 2. Here it is in the numerator pi 3 by 2. Here in the denominator pi 3 by 2 will get cancelled. So we will get only here 4p over m 3 divided by 2 minus 3 divided by 4. Now we will simplify this. Now we got that the expectation value of the kinetic energy is 2 h cross squared p over m multiplied by 3 minus 3 over 2 minus 3 over 4. So this term inside the bracket will become 3 over 4, and this 2 and 4 will get cancelled. This will become 2. So 3 by 2 h cross squared p over m. This is the kinetic energy, expectation value of the kinetic energy. Now next task is we have to find the expectation value of the potential energy. So this is very well that by definition the potential expectation value of potential energy is integral psi star b psi. So we psi t tau, that is very important. So t tau I have replaced 4 pi r squared t r as usual, and the potential energy V is equal to minus E squared over 4 pi epsilon naught r, except 1 over r. All other thing I am bringing outside the integration because these are constant. That is minus E squared over 4 pi epsilon naught, and I am keeping 1 over r. Of course, this is the wave function, this and this. And with normalization constant, square of the normalization constant, modulus A squared. So here you can rewrite this. 4 pi you take outside, 4 pi. Then this r and r squared will get cancelled and this will become r. So you will get 4 pi outside. Then integral between minus infinite to plus infinite r e power minus 2p r squared d r. This is the Gaussian. This is the Gaussian integral. So for Gaussian function, the integral between minus infinite to plus infinite x e power minus alpha x squared dx is equal to 1 over 2 alpha. This is spread in the Gaussian function. So here alpha, in our case, alpha is 2p. So this integral will become uh, 1 over 4p, because 2 times alpha, that is 1 over 4p. So I am replacing 1 over 4p. 4p. So after simplification, uh, that is minus, we will get the expectation value of v is equal to 2 square root of 2p over square root of pi e squared over 4 pi epsilon naught. Here this simplification, how we arrived, it's very easy. You can cancel this pi and this pi. Then what about other parameter? You can cancel this 2p with this 4p. You will get 2. So then you have a square root of pi. So here you have 2. Then sorry, this 2 will get cancelled with this 4. You will get 2. So ultimately in the numerator you have 2, of course with the negative sign, 2 square root of 2p. In the denominator you have square root of pi and this terms e squared over 4 pi epsilon naught. Now we will move further. Now the total energy, that is expectation value of Hamiltonian, is equal to the sum of the expectation value of kinetic energy plus the expectation value of potential energy. So we have seen the expectation value of kinetic energy is this one and the potential energy is this. Now we have to find the minimum energy level. So with respect to P, you will get minimum energy level. If you differentiate minimum or maximum, you will get 0. If you differentiate first term with respect to P, then you will get 3 h cross 3 by 2 h cross squared over m, because this P will go away. Similarly, if you differentiate square root of P, you will get 1 over 1 over this is 1 over square root of p. P will come to the denominator, because this can be written as p power half. If you differentiate, you will get sorry, mine. Okay. If you differentiate, you will get 1 over 2 p minus half. So this will become in the denominator, and this 2 will cancel with this 2. So you will get the square root of 2 uh, divided by square root of pi p and this term, which is equal to 0. That means you bring this negative term to the other side, then you will get 3 by 2 h cross squared over m is this one. Here all other things are constant except p. So from this you can calculate p and you substitute this value of p here. Then you will get minimum expectation value of energy is equal to minus 11.5 electron volt, which is exactly matching with the lowest energy of hydrogen atom. Thank you very much for watching my video and supporting me continuously.